So today we're going to talk a little bit more about uncertainty. So every measurement we take has some degree of uncertainty. Understanding this really helps us interpret results correctly. So for example, we have a meter stick, and a meter stick is divided into millimeters, meaning that the smallest unit a meter stick can read is 1 millimeter. And, you know, when looking at the millimeters, we can see that there's just enough to make another cut to that millimeter. So we would typically go by 0.05 millimeters. This means that every distance measurement we take has some built-in margin of error. So not all uncertainties can come from an instrument's position. Some come from consistent biases, and these are called systematic uncertainties. So we know that a clock has a 1 second uncertainty, a 1 second, a 1 second, come on, a 1 second, that way, no, has the smallest unit is 1 second. And we still have some little wiggle room that we could tell that we could do half a second. So systematic uncertainty here could be that the clock is over 100 years old. So that means that we need to that means that the clock could be measuring a whole second later. So for example, if this clock runs 1 second slow, every timing measurement we take is off by the same amount. Unlike instrumental uncertainty, which varies with each measurement, systematic uncertainty skews all the results in one direction. So let's look at an example. So in this case, we'll measure the speed of a Jayhawk. We know that the velocity of the Jayhawk is some change in distance over some change in time. So if we use the meter stick to measure the distance and a clock to measure the time, we can use that. Okay, we can use the meter stick to measure the distance and the clock to measure time. But because both of those have some uncertainty, our final velocity will also include some uncertainty. So if we plot the data, we tell the Jayhawk to go some distance, and we measure the time, we measure the distance, we can plot the data, and we could see that there are some error bars in each of our, if we can see that there's error bars on each of our measurements. So if we took multiple trials, we would see variations on our values. Larger uncertainties means that there's less precision in our final velocity. So let's say that the total uncertainty on the clock is greater than the total uncertainty of the clock or the stopwatch, should be stopwatch, is much greater than the uncertainty of the meter stick. So that means as we increase our measurement on our time, so that means as time increases, the uncertainty in the time will dominate over the uncertainty of the distance. So if we had some measurement taken up here, our uncertainty on our time would grow much larger than the uncertainty on the distance. Whoops.